Got to give the people, give the people what they want. Bass back in the streets out here doing it. Today we just got 3 practice problems, but we're going to be factoring complex quadratics. And by complex, just the numbers give you more combinations that you can deal with. But it's no different. It's no harder than what we've done here, and you guys have been doing a good job. So why don't you copy this first one down? And actually, how I want you to do this is I want you to factor it right now before I do it and see if you can factor it. And then I'm going to do it, and you can check, all right? Now, you could do that or you could not do that. That's up to you, but that would be the way that I would suggest. All right, so here we go. Let's see if I'm going to factor this bad boy. I see that this has no GCF, no common factors between 9, 24, and 20. So I'm going to go straight to using my area model. And say this is a 9x squared. This is minus 20. So that means when boxes 2 and 3 multiply together, I should get a negative 180. And when boxes 2 and 3 add together, I should get 24. This is where I mean of more complex. This is where I literally have my calculator right next to me. And I'm saying, okay, what are all the things I could multiply? I don't know why I did that. All the things I could multiply to get 180. And I literally go down the list. 180 divided by 1 is 1. 180 divided by 2 is 90. And for these pairs, I'm looking, could I add or subtract them to get a 24? No way for these. 180 divided by 3 is 60. And again, I'm just doing this in my calculator. 180 divided by 4 is 45. None of those still get me close to a 24 if I'm adding or subtracting them. 180 divided by 5 is 36. Getting closer, but not quite. And 180 divided by 6 is 30. Ooh, snap. I see I could subtract 6 and 30 and get 24. That's probably going to look good. So that means I need a negative 6 and a positive 30. All right, perfect. I'm in good shape. So now I have a negative 6x and 30x. That goes here. Now I'm going to figure out, okay, how does this work? So now there are 2 ways that I could get 9x. I usually start with 3 and 3. And looking at this, going this way, these are both multiples of 3. So that looks good. And going down this way, 9 and 30 are both multiples of 3. So that looks good. So I'm going to roll 3x and 3x, which would give me 9x squared. 3x times 10 is 30x. 3x times negative 2 is negative 6x. And negative 2 times 10 gets me that negative 20. I am in good shape. I just factored this. So that means it was factored to 3x plus 10 times 3x minus 2. Bong bong, that's the first one. Hopefully you got that one without me. But use this strategy of breaking down the factors of whatever you need to multiply. It's very useful. Let's move on to example 2. And again, this is just practice. Let me see what's my next question. It says 10x squared minus 3x minus 18. Okay? So now again, I'm looking for a GCF, but nothing goes into 10, 3, and 18. So go straight to my area model again. Oh, again, did you pause and do this beforehand? I hope you did. Don't be a liar. You're only lying to yourself. So I'm saying this is 10x squared, and this is minus 18. Look at this again. I get that lovely negative 180 again. But this time I need my middle term to add to negative 3. Looking back at what I've already done for 180 up here, none of these numbers could I add or subtract together to get a negative 3. So I'm going to start by adding more factors of 180. Let me see what I could use. 180 divided by 7, let's see. 180 divided by 7 doesn't work. 180 divided by 8 is 22.5, so that's not good. 180 divided by 9 is 20. But I can't add or subtract those to get a 3. 180 divided by 10 is 18, and I can't add or subtract those to get a 3. 180 divided by 11 I know doesn't work. 180 divided by 12 is 15. Woohoo! Look at that, look at that. 12, 15. I could subtract those to get a 3. So let's see and make sure I get this right. Negative 180, and I need a negative 3. If I have 12 and 15, I need the 15 to be negative, so I get a negative 3. All right, negative 15x, 12x. All right, moving on. So now there are multiple ways I can get 10. I could do 1 times 10, or I could do 2 times 5. So let me think about what makes sense. If I do 1 times 10, well, if I put the 10 here, these are not multiples of 10, so that's not going to work. If I put the 10 here, these are not multiples of 10, so that's not going to work. So now I'm going to move it to 2 and 5. And just looking across, I see, oh, those are multiples of 5. These are multiples of 2. 2 and 5 is looking pretty good. 2x, 5x. Let's see. And 2 times 6 would give me 12x. 5 times negative 3 would give me negative 15x. And negative 3 times negative 6 is a negative 18. This is looking beautiful. This factors to 5x plus 6 and to 2x minus 3. Lovely, lovely, lovely. One more. This will be the last one. Example 3. Says 40x squared plus 125x plus 90. Why don't you go ahead and do that one first? And I'm going to give you a hint. You should probably look for a GCF. All right. Hopefully you just did that. And hopefully you recognized, oh, 40, 125, and 90. There's definitely a GCF there. All of these are multiples of 5. So I'm going to go ahead and factor out 5. So 40 divided by 5 leaves me with 8x squared. 125 divided by 5, I don't know. Let me do that in my calculator. That leaves me with a 25x. And 90 divided by 5 is 15. So now I have 2 factors. And now I need to break this remaining quadratic into more factors. So I know it doesn't have any GCF now. Now I can go ahead and use my area model. So we have 8x squared and we have 15. Okay, so that means blank times blank equals, I don't know, what is 8 times 15? Put that in my calculator. Oh, 15. Wrong. My bad. I meant to write 18. Let me go back here and erase this. Hopefully you caught that as well. This should not be 15. This should not be 15. This should be 18. Let me just double check that. 90 divided by 5. 18, yeah. This should be an 18. So 8 times 18 happens to be 144. And those two need to add to the middle term, which is 25. Right? So I'm going to start again with my factors of 144. 1 and 144. There's no way that's going to turn into 25. 144 divided by 2 is 72, but that's not going to be a 25. 144 divided by 3 is 48. That's not going to turn into 45. Divided by 4 is 36, which is not going to get me there. I know 144 can't be divided by 5. 144 divided by 6 is 24. Getting closer. Not quite. 144 cannot be divided by 7 evenly. 144 divided by 8 is 18. And 144, 8 and 18 would give me what? 26. Close, but not quite. 144 divided by 9 is 16. Ooh, 9 and 16. 25. Right? So to get, and it's both positive. So this is just a positive 9. This is positive 16. We're good. 9x, 16x. Now let's look here again. To get 8s, 2 times 4, right? These are multiples of 2, which is good. These are not multiples of 4, so that's not good. These are multiples of 4, which is good. But again, these are not multiples of 2, so that's not going to work for me. My other option to get 8 is 1 times 8. I'm seeing that these are multiples of 8, and these are multiples of 1. That's looking like that could work out kind of lovely. So let's go ahead with the 8x here and the 1x here, which makes this a 2, which makes this a 9, and most importantly, 9 times 2 gives me that 18. I am in good shape. So I just factored this to, and here's the mistake that you all are going to make. You're going to tell me it's 8x plus 9 times x plus 2. What'd you forget? Oh yeah, you forgot that you factored out that 5 to begin with. This is the fully factored answer. So don't forget, I'm telling you now, you have a test next class on Thursday or Friday, depending on when you have class, and it's just on factoring. It's just straight up factoring. You're going to practice it more in class, next class, and then you are going to take your weekly test on this. So, test on Thursday/Friday. And it's a straightforward factoring. All right? Have a great day.